Well, hey kids, thanks for joining us on Science Sundays for your week of science lessons. I'm Chief Meteorologist Elaina Rusk here at 23 ABC.
And I'm Meteorologist Brandon Michaels here at 23 ABC.
And we're so excited to do kind of a couple of our favorite environmental experiments that we tend to do when we bring meteorology into the classroom. Obviously, with the pandemic, we can't visit your classrooms, so thank you very much for letting us come to you via video today.
Yeah, it's going to be a lot of fun. I'm going to show you one that you haven't seen before, and you're going to show me one I haven't seen before.
Exactly. So I would like to start with yours because I'm very intrigued. What do you have here?
This is my favorite experiment whenever I go into classrooms. It's called the cloud in the bottle. You can probably predict what's going to happen from there. We're going to form a cloud in this bottle, and I like it because it's got a great visual. It's kind of fun. It's very simple too. You don't really need any fancy equipment whatsoever. So all you need is a 2-liter bottle, a clear 2-liter bottle like this, little tiny bit of rubbing alcohol, some type of a bicycle pump, and then I've got the tip of that fit with just a valve stem that you'd put on a tire. So we're going to start by just putting a little bit of this rubbing alcohol in the 2-liter bottle, trying our best not to spill, but definitely spilling no matter what.
Every time.
Every time. Every time I do this, I end up with a little bit on my clothes here. So we're going to put the cap on it.
Okay.
And what we're going to do is just kind of swirl it around a little bit, because this is going to work with the vapors of the rubbing alcohol. And the more surface area we get, the more vapor is actually present.
Perfect.
And then we're going to take the cap off. We will put the valve stem right in the top of the bottle, and then it becomes a 2-person job. So we're going to have you do the fun part here, Elaina.
And I hold the cap on tight, make sure it doesn't pop out?
Exactly, because we're going to put a lot of pressure in this bottle using this bike pump. So I'm going to do probably 3 or 4 pumps.
I can feel it getting tight.
Yep. And that should be good right about there. Now, here comes the fun part. Go ahead and 3, 2, 1. There we go. A cloud in a bottle. It's so much fun every time.
It really is. And I love seeing it coming out of the top as well, and you see it swirling.
Mm-hmm. And you'll see eventually it'll kind of like work its way down as some of that air seeps out a little bit too.
Absolutely. So tell us what just happened. What's the science in this?
So what we're seeing is condensation, just like we see in the actual atmosphere, how clouds form. We know that warmer air can hold more moisture, or in this case rubbing alcohol, and the colder air can't hold as much. So eventually reach a point where that air can't hold any more vapor or water, and it condenses out and we end up with clouds. So what's happening here is when we let that go, the pressure releases and we see that temperature drop very quickly.
Yes.
And we see the condensation.
Fantastic. And this also reminds me a lot of the Thule fog here. You're heading into your first Thule fog season with us. November, December, January, February are our fog months here in the Central Valley. And it's very much like this. We'll start in the morning with that really dense radiational fog. And it's because we have that inversion layer over the top. No wind to mix it out. Usually happens within a day or two after a heavy rain event. For us, heavy rain is a 10th.
Okay.
Brandon comes from the northern states.
A lot wetter place.
You know a lot more rain than that. But for us, that's considered good saturation. We have all of our moist ag land. And so as that soil holds on to that saturation, and we then get that cold sinking air in the inversion over the top, boom, you get that moisture like this bottle. And we're the ones in the Central Valley. And then as the day goes on, usually about 9 a.m., starts looking like this.
Starts to mix out a little bit.
You see it mixing out, and then suddenly you're at lunchtime and everything's great. The kids love fog days because they get those fog delays, right?
Ooh,
not
fun.
so much fun for drivers.
Probably not.
Yeah, amazing. So, speaking of rain, this is my favorite experiment. I'm gonna hand you a teeny tiny cup of water.
I'm just gonna get this out of the way.
Perfect.
Okay.
And this is, you did cloud in a bottle, rain in a cup.
All right.
This is my favorite experiment. And it's kind of cool because I'm gonna use just some good old shaving cream here. And kind of like a sundae, we're gonna create a big frosting cloud on top. Oh, that's a good one.
All right.
So go ahead and make your cloud.
Mine is not going to be that nice, but I am going to try. You are practiced hands at this, I can tell.
And then we can use it to clean up the desk later, which always helps.
Fantastic.
Perfect. So you have a nice cumulonimbus over there, a towering cumulus if it were. So all of this down below, it's water obviously. Just pretend like this is our calm air, right?
Sure.
And this is cumulus cloud, big puffy white cotton ball cloud. This tends to form after a storm, right? After on a clear, calm day. But let's pretend like this is a darker gray cloud that's forming as the storm is coming in.
My cloud is tipping over just a little bit. There we go.
Straight up and down helps, but what we're gonna do is take some very messy blue food coloring. I always get this all over my hands. And we're gonna add a couple drops into our cloud. And this is a good lesson in saturation. Nothing's coming down yet.
No.
So those clouds keep getting heavier and heavier and heavier, right? They're carrying more and more moisture until all of a sudden they can't hold it anymore. And then what do you think is gonna start happening?
I imagine we're gonna see something like rain.
it will start to rain down below. And I love this because you see it falling very slowly. It's just a really cool visual for the kids. A really messy one. Looks delicious, not tasty.
It doesn't smell great, but it looks pretty cool.
But then also the thing I love about this is as it comes down and hits the ground, it fans out, and that can show you what happens in a downburst
just like that.
with a collapsing thunderstorm, which doesn't happen here very often, but it can.
Yeah.
And you can get those heavy rain shaft columns off in the distance.
Cool. All right, I'm going to give this a try. I'm excited here. So first we'll just try a couple of the drops. And like you said, nothing really happens, but eventually if we keep adding more and more, I don't know how much to add here.
See, that's what I love about this experiment is you don't know how much that cloud's going to hold until now you've got some rain.
Now we got some rain coming down and hitting the ground. That is so cool.
Isn't that cool?
It's a great visual too, like you
It's a great visual. I love it. And it also shows that clear delineation of that lifted condensation level. So the lifted condensation level, from that point, the clouds will start forming until they can't form anymore. And especially in a thunderstorm, you can get that anvil on top. You can get hail that's being tossed up there. So it's a great lesson for the older students in the different atmospheric levels of a thunderstorm.
Different layers you get inside that storm. Oh, that's so cool. And you can actually kind of see it coming down just like rain shafts. Just like
exactly.
you said. That's really neat.
Thanks, kids. We'll see you next time.